If you missed class and you're trying to make up this set of notes by watching this video, please be aware that we actually did these notes through discussion format during class and that you might find some value in having some of that discussion with one or more of your classmates when you return. We did watch a video first, and the link to that video is on the website, and it's just the Ionica Smoots causation versus correlation video. So I would recommend going and watching that video before you take these notes. So when I look at this graph, one of the things I notice immediately is that there's a strong correlation and a negative correlation between these two variables. Remember, the negative correlation doesn't mean it's weak. It just means as one of the variables increases, the other decreases. So I notice that yes, there is a strong correlation because this negative 0.92 is between negative 0.8 and negative 0.99. But is there causation? Well, no, and on the surface of it, it seems absurd to even say that the number of pirates in the world has any influence on the global average temperature or global warming. But this is an absurd sort of example to something that people do all the time. They see a strong correlation between two variables, and they want to say that one then causes changes directly in the other one. And that's not necessarily true. The other thing, as you should have seen in that video that Ionica Smoots did, is sometimes there's a strong correlation, but we're supposed to be looking at our independent variable and does it cause our dependent variable. And there was one situation where she was talking about how it was actually reversed. So when we're asking if there is causation between these variables, what we are asking is, does the independent variable directly cause changes in the dependent variable? No, the number of pirates in the world doesn't directly impact the global temperature. But what did happen is time is the connecting factor in this case. And what I mean by this is, over the years, there have been fewer pirates at the same time the Earth has seen increases in temperature. Now, we could make a graph that's very similar. We could talk about any two things that are changing over time and then do a scatter plot of those. So we could look at things like the sales of iPhones and the amount of forest acreage in the world. Well, more and more iPhones are being sold all the time, or let's just say smartphones, and we're losing rainforest. But it doesn't mean that because people are buying iPhones or buying smartphones that that's directly killing the trees. So this is sort of one of those examples where it's really time that's impacting, or the passage of time is changing both of those. Another one that's kind of absurd on the surface is, hey, you know what? We have fewer lemons imported from Mexico and highway deaths have also decreased. Correlation coefficient between those is negative 0.98. So is there a strong correlation? Yes, because that's closer to negative 1 than negative 0.8. And from negative 0.8 to negative 0.99, it's strong. Is there causation? Why or why not? No, this is another one where over time the imports have decreased, as have highway deaths. It's just that maybe we have another place that we import lemons from, so we don't import as many from Mexico as we used to. Maybe Mexico produces fewer lemons than it used to, so we can't import as many. Whatever impacted that particular variable, I don't know. but just over time we have imported fewer lemons from Mexico. In the same time, there have been some significant changes in auto safety issues, in enforcement of traffic laws that would also decrease the number of traffic fatalities. One does not directly impact the other. So those are two sort of absurd situations where you would never think that one of those things causes the other one. This one, however, is something that you would see on the news, where they say, you know, studies have shown that increased intake or people who eat more animal fat, so you're eating more meat, those people see an increase in deaths from breast cancer. So there has to be something where eating animal fat causes breast cancer. And you know what? Is there a strong correlation? Yes, it's at 0.90. Now, it's not as strong as the other two we looked at, but is there causation? Maybe, but we don't know. The other two is obvious that no, there's no causation. But we can't prove this. There are other factors that could affect both of these. For example, wealthier nations can have people who can afford to eat more meat. So they have more people who can afford to eat more meat. It is possible that the increased use of chemicals in those countries could be the thing that impacts, or the thing that increases breast cancer rates. So in developing nations where people don't have very much money, they can't afford to eat a lot of meat. They also don't use a lot of herbicides and pesticides and household chemicals, and they don't have the big smokestacks and all of those things going that we have in this country. Is it possible that eating animal meat and animal fat increases breast cancer? Maybe. It's not at least as absurd on the surface as the other two, but there are so many different variables that go into this that we can't say that there's a direct causal link between the two of those unless they do scientific studies to prove that link. That's the difference between correlation and causation.